Welcome to BeeGraphy. Today, we'll create a parametric, undulating form using nodes, starting with basic points and transforming them into curves and surfaces. Let's begin. This BeeGraphy tutorial shows how to create a parametric, undulating 3D form using nodes. It covers creating curves from points, generating undulations, adding width, lofting, extruding for thickness, and applying materials. The tutorial emphasizes the power of parametric design by offering interactive control over parameters like curve shape, undulation count, thickness, and material properties. We start with a construct point node, which creates a point at the origin 0, 0, 0 of our 3D space. We then use two move nodes to reposition this point. The first move uses vector x and a number const, 20, to move the point a fixed distance along the x-axis. The second move, coupled with vector xyz and three range input sliders, x, y, z factors, creates a second point whose position we can interactively control in all three dimensions. These 2 points define the starting and ending points of our first curve. We can modify the parameters of the points. The polyline node connects these 3 points, creating a straight line segment, our first curve. We will move the variables to the left side for better convenience. Now, for the second polyline, we will also obtain 3 points. Now we will move the initially constructed point along the vector in the y direction. We will set the size to a constant value of 30, which will be the width of our model. And now, we will move the shifted point by the same magnitude in the vector x direction. Now, the point moved in the vector y direction will be shifted, and it will be our third point. The third point will now be moved in the direction of the vector xyz. We will set the magnitude of the vector in the x direction to 15 and in the z direction to 20. With those resulting points, we will now construct our second polyline. The core of the undulating effect comes from the tween curve node. It takes 2 curves, our polylines, as input and generates intermediate curves between them. The factor input controls the degree of interpolation. To create multiple intermediate curves, we use list sequence SEC. This node generates a list of numbers within a specified range. We connect a number const, 0, to the start input, 1 to end, and 10 to count. This produces a list of 10 numbers from 0.1 to 1, which, when fed into the tween curve factor, generate 10 different intermediate curves. We will move the variables to the left for better convenience. To give our curves some width, we use offset curve. It creates parallel curves a specified distance away from the input curve. We connect the tween curve output and set the distance to 2. Now we will use 2 graph tree nodes. Graph tree is essential for organizing the data. Because the tween curve output is a tree of curves, 1 branch for each factor value, we need to graft both the original tweened curves and the offset curves so that the loft surface node can create surfaces between corresponding curve pairs. We add thickness to the surface with extrude surface. Vector y defines the direction of extrusion along the y-axis. We will create a range input node, setting the minimum to 1 and the maximum to 5. And a range input slider labeled thickness allows us to control the extrusion amount dynamically. By changing the thickness value, you can see the result. We will move the variables to the left for better convenience. The final touch involves enhancing the visual appeal of our spiral tube by applying material properties. The Apply Material node allows us to structure a realistic appearance by setting parameters such as color, metallicity, roughness, and opacity. Apart from the variables and the Apply Material node, we will group the remaining nodes and collapse them to make the final result more understandable. Thanks for watching. We hope this tutorial helped. For more on computational design, please like this video, subscribe to our channel, and hit the bell icon to get the notifications. See you in the next tutorial.